Welcome to the next video on functions. In this video we're going to be talking about
linear equations.
Go away.
No.
I knew he was going to haunt me.
Yep.
I knew he was going to haunt me for the rest of this module. Anyway, just go away. Alright, we're going to basically, like he said, talk about linear equations. Simply put, a linear equation is an equation that when you graph it on a Cartesian plane makes a straight line. Nothing really complicated about that. And in order to do that, we need to know a couple of things. The biggest thing that we need to know is what's called slope. And a slope is basically this. It is the steepness of a line expressed as a ratio using any 2 points on a line. Alright, and we usually express this by using this equation. M is equal to y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. So the question is, what does this mean? So let's cut on to the dot cam and let's talk about it.
What is slope? Baby, don't hurt me. Don't hurt me.
Oh Lord, I'm not going to get that tune out of my head. Alright, what is slope? Alright, so basically this, you've got the equation y sub 2 blah blah blah. This is really what we can simply say. It's a vertical change. It's our vertical change. In other words, how high did it go up or down, versus our horizontal change, which is basically saying how far did it go left or right. That's really all our slope is a vertical change over horizontal change. Personally, I like to use the terminology, can't talk, rise over run. How far did it go up or down, and how far did it go left or right, basically speaking. So let's actually kind of use some numbers here and kind of show you what I'm talking about. So straighten up the papers. So let's do this guy. Let's say I have 2 points. I have 2 and -3, and I have 5 and 3. Alright, so what I'm going to actually do is I'm going to graph these 2 points. So I'm going to say 2 and -3. So 2 and -3 is here. And the next one is 5 and +3, which is here. And so let's go ahead and connect our dots. Connect our dots, la la la. Pee Wee Herman reference, check. Alright, so we have that taken care of. Alright, so what we're actually wanting to know is what's our slope. How high, or what was the difference between this dot and this dot. And the way we do it is, from a graph, is literally just kind of see how many times it changed. So we went down, so let's go 1, 2, 3, 4, 5, 6. So there's a 6 here. Alright, so we'll just kind of remember that. So basically from this point down to here is 6. And now from here it's 1, 2, 3. Okay, so basically think of it like this. If I started here and I went here, I basically went to the right 3 and up 6. And so I can write this. I had a rise of 6. I had a run of +3. Now, wait a minute. Let me explain something here before I forget. Notice that I went to the right. And since I went to the right, going to the right on a Cartesian plane is always positive. Okay? Since I went to the right. And since I went up, that's also positive. Up is also positive. So if I happened to go down, it would have been a negative, and if I went left, it would have been a negative. So this is really saying +6. I went up positively, and I went to the right positively. And so we can really simplify this and say that my M is simply 2. That's my slope. Another way we can say it is 2 over 1. This is a big thing. You may see slope written as just a whole number, but always remember, it's a fraction, 2 over 1. Alright, and wow, something's really going bad in the background. I'll have to check on that. So coming right up, I'll be back. Alright, sorry about that. My boy, he just started crying. I guess he just needed some attention. So he's going to be with us for a few moments. Alright, hey, we're just not going to stop teaching. I don't care if I got a kid or not. All right, so let's look at those same points that we just did in the last clip, and we're going to actually use the equation. So we used 2 and -3, and we had 5 and +3. All right, so we have this equation, m is equal to y sub 2 minus y sub 1. Well, what's all this mean? This is what I want you to look at. Basically this, we started at this point right here, 2 -3, and we went to 5, 3. So this is our first point. So we're going to label these as x sub 1 and y sub 1. And if this was our first point and this was our second, this is going to be x sub 2. Is that a good pen? It is? Okay, wipe your mouth. X sub 2 and y sub 2. Now that we've labeled it, knowing that this is my first point going to my second point, we're simply going to start plugging in numbers. All right? So y sub 2 is going to be 3 minus y sub 1. Boy, stop that. Over 5 minus 2. Let's solve for it. Well, 3 minus a -3 equals 6, and 5 minus 2 equals 3. Are you happy now? All right. So, equals 3. Well, doesn't this look familiar? It's the same thing we got a while ago when we did our graph. When we simplify this again, we get 2 over 1, or simply our slope is 2. All right? So what I want you to do now is I want you to try these on your own. What is the following thing? Hey, hon. Yeah, he's fine.
Alright, sorry.
Alright, so back, and now I've got Polly and my mother's dog in the video now. Wow, you're just seeing the whole family today. The first slope is m is 3/5, so it has a positive up of 3 and a positive right of 5. And the next one is m is equal to 1. Alright, so let's go on to the next page. Alright, so this problem says draw a line that goes through the ordered pair of 3, 4 with different slopes. So how does this work? Basically, the first thing you need to do is plot where 3, 4 is. So we find it. Here's my 3 on my x-axis, there's my 4 on my y. We find where they meet and we put a dot there. Alright, so there's 3, 4. So I'm going to slide this up and let's see what we can slope. So the first thing that I want to do is I want to find a line that goes through 3, 4 that has a slope of 2. Alright? Now remember, slope is always said rise over run, or basically the vertical change over a horizontal change. Well, we can rewrite a slope of 2 as simply this, 2 over 1. Now notice that this is positive, so that means that I'm going to go up 2 and to the right 1. So I'm going to go up 2 and to the right 1. I'm going to go up 2 and to the right 1. And this process can continue forever and ever, but I don't want to do that. So we're going to draw our line. So I have made my line that goes through 3, 4 with a slope of positive 2. Alright, so let's try another one now. Let's use a different color. Let's say that my slope is -3. Alright, well, this is telling me that I have a slope of -3 over 1. Now, this negative has to go with either the top number or the bottom number. It really doesn't matter. I like just kind of, you have to choose sometimes. So in this case, I'm going to say it's going to be -3 over 1. All right, everybody understand that? So I'm going to start back at my point, and then I'm going to go down 3, because that says negative, and I'm going to go to the right 1. So I'm going to go down 1, 2, 3, and to the right 1. Then I'm going to go down 3 again, 1, 2, 3, and over to the right 1 again. And I can continue this process, but I'm not. I've got enough points. And I have drawn my second line. All right, let's do one more, and I'm going to get you to try this one on your own. Let's say that the slope is negative 3/4. All right, so the slope for this one is negative 3/4. You want to start with your point 3/4 and draw your line. Okay, pause your video and come back.
You shouldn't have something like this red line right here. It started at 3/4, then it went down 3 to the right 4, down 3 and to the right 4 again. All right, that's how we do it.
All right, now that we know how slope works, we can actually use that information to help us take an actual equation and graph it. So how do we do that? The best way that we take an equation is by rearranging it and putting in what's called slope-intercept form. And this should be familiar. It's y equals mx plus b. All right, so what does that mean? Well, the m we already know to be slope. All right, we know what our y and x mean. Those are basically the ordered pairs, or the independent and dependent variables. All right, and then now this part is the y-intercept. Well, that is going to be our b, and simply put, this is where our line crosses the y-axis. So let's go back and look at a picture right here. So this is one that we had a while ago. In this first one, if you kind of look, this purple one right here, it actually crosses the x-axis right here. So if this was b, we would say b is equal to -2 because it crosses the y-axis at -2. All right, so that's really what y-intercept is. It's where the line crosses the y-axis. All right, now let's go ahead and try some. All right, so we have in this one y equals 3x plus 1. Well, when we have it in this format, we know that our slope to be 3, or basically 3/1, and that our b is going to be 1. All right, and that's our y-intercept. So let's go ahead and graph this. First thing that we need to graph is where our y-intercept is. Well, it says 1. So we come to our y-axis, we find 1, and we graph it right there. This is where our line is going to cross. And now we're going to use the slope. Well, it tells us that we're going to have a positive 3, or we're going to go up 3, and a positive 1. So we go to the right one. So we're going to go up 1, 2, 3, and to the right 1. And we go. We put our next dot. And we can continue this out, but I'm not. And this is pretty much it. I'm done. I have just graphed my line. I had to find my y-intercept, which was 1, plotted it, and then use my slope to go up 3 and over 1. All right, let's try the next one. We have y equals -4/5 x minus 2. Well, what's my slope? It's going to be -4/5. What's my y-intercept? -2. Alright, so what do I do first? Well, the first thing I got to do is plot my y-intercept, which is -2. So I come to my y-axis, I plot -2. Right there. Now I use my slope. It tells me to go down 4 and to the right 5. So I'm going to go down 1, 2, 3, 4, and then I'm going to go over 5. 1, 2, 3, 4, 5. And I can continue this. I can go down 4 over 5, but I'm not, because all I really need is 2 points. And I graph it.
Alright, I want you to try this one on your own.
Alright, so first off, you're probably stuck on this one. Let's be honest. This is not like anything I've shown you before. Why is that? Well, this is not in what we call y-intercept. Notice how that the y and the x are on the both sides. So the first thing that we really need to do is actually solve for y. Okay, so we're going back to a skill that we learned all the way back, I believe in module 1, not module 1, but the first set of videos that we did. All right, so what are we going to do? Well, we need to get x to the other side, so we're going to add x to both sides. In doing so, we get 2y is equal to negative 6 plus x. All right, I'm going to rewrite that because I just don't like that. I'm going to say 2y is equal to x minus 6. Hopefully you understand how I went from here to here. I just don't like having the x at the end. Now I'm going to divide by 2 on both sides, and I get y is equal to 1/2, because there's a 1 here, so 1 divided by 2 is 1/2 x, and then negative 6 divided by that 2 is going to give me 3. So I get y is equal to 1/2 x. Can I graph this now? Yes, I can. So my slope is 1/2. My intercept, y-intercept, is negative 3. All right, so let's do it. Negative 3, we put it on our y-axis, right, which is right there. This tells me I need to go up 1 and to the right 2. And I can continue this by going up 1 to the right 2, but I'm not. And I've got 2 points, that's all I really need. And I just draw my line. And I have graphed it. So when you get an equation like this, it's best to remember to rewrite it in y equals mx plus b form. Try to get, basically what you're saying is solve for y and then graph it. Lastly, we can also graph lines by finding what's called x and y intercepts. Okay? So x and y intercepts. We already know what the y-intercept is. It's basically whenever the line crosses the y-axis. Thus, it stands to reason that the x-intercept is simply where the line crosses the x-axis. All right? So, how do we go about doing that? Well, let's look at it. Let's do a graph. So here's the thing. I wanted to show you this first before we actually do a problem. When we cross the y-intercept, let's just say here, it doesn't matter where we cross it, the x will always be 0. So when we cross here, it's going to give me an x of 0. All right? So that's something important to remember. Whatever the y-intercept will always have a value of x as 0. Now the opposite is true. When we cross the x-intercept, notice how that the y-intercept, notice how the y value will be 0. So whenever we cross the x-axis, no matter what x is, the y will always be 0. So that rule kind of helps us in finding things out. So let's graph this equation. Let's say 2x minus 3y equals 6. And the first thing I want to do is find the y-intercept. Well, to find the y-intercept, I need to realize that x is going to be 0 because of what I just showed you. All right, so we're just going to plug in 0 in the place of x. And when we do, we can solve for it. We find out that that cancels, goes away, and we get negative 3y equals 6, and we find out that y is equal to negative 2. So the first point that we just found out is going to be 0, negative 2. This is our y-intercept. This is where it's going to cross the y-axis. All right? Now let's do the x-intercept. Now, in order to find the x-intercept, we need to understand that our y is going to be 0 this time. So we're going to say 2x minus 3 times 0 equals 6. Well, this is going to give us 2x is equal to 6 and x is equal to 3. That's telling me that my x-intercept is going to be at 3, 0. All right. Knowing these 2 points, I can plot things. So let's go to our graph. My y-intercept is 0, negative 2. So here's 0, and I'm going to negative 2. This is where my line is going to cross my y-axis. That's why it's my y-intercept. Now let's write 3, 0. Well, here's 3, and this is 0, and this is where my line is going to cross my x-axis. All right, and I now have my x-intercept. Wow, the children are wild. Any of you out there, parents, understand what I'm going through right now? All right.
Please forgive us.
All right. So when we graph this, we graph the intercepts. We had the x-intercept, the y-intercept. We connect the lines, and we're done. Now, a lot of people like this method because they're just finding the 2 points and they don't have to do the rise over run. I don't know. I like the other method better. I like using slope-intercept form. To me, it seems less work. So, whatever method is best for you, I'm pretty much good with. However, I need you to know how to do both things. And I'm going to have to check on my children. Be back. Sometimes you may need to find if an ordered pair actually is a possible solution to an equation. Basically, really what you're asking is, does this point that I'm giving you fall on the line that you see in this graph? So let's go ahead and write straight to it. Are the points 2, 2 and negative 4, 2 solutions to the graph below? So really all we're trying to find out is, does this ordered pair 2, 2 fall on this line? Well, let's find out. Well, let's find 2. Well, here's positive 2 and then there is positive 2 here. So does it fall on my line? Yes. So the ordered pair 2, 2 is, yes, a solution. It is a solution because it works. What about negative 4 and 2? Well, let's find negative 4. Well, it is over here, and then we go down to, up to a positive 2. Well, does this fall on the line? No. So we can say negative 4, 2 is not a solution. And that's really all this is does this point fall on this graph? And if so, that makes it a solution. All right, so let's look at the stuff down at the bottom. So what happens if you have an equation? Now, a while ago I showed you a graph. Does the point fit the graph? Well, what happens if your equation is points 3 and 4 and 5 and 1/5 solutions to this equation? 3x plus 5y equals 29. Well, this looks complicated, but it's not. Really, all you're going to do is plug these numbers into your equations. You should know by now that 3 is our x value and 4 is our y value. So let's plug it into our equation. 3 times 3 plus 5 times 4 equals 29. Well, 3 times 3 is 9, plus 5 times 4 is 20, equals 29. 29 is equal to 29. So is 3, 4 a solution? According to this, yes it is, because both sides are equal. So yes, 3, 9 is a solution. All right, so let's look at the next one. We're going to do the same thing. We know our 5 is x. We know the 1/5 is y because this is an ordered pair, so we're going to plug it in. 3 times 5 plus 5 times 1/5 equals 29. Well, 3 times 5 is 15, plus 5 times 1/5 we know to be 1 equals 29. 15 plus 1 is 16 equals 29. Now look, does 16 equal 29? No, it doesn't. 16 does not equal 29. That means that the ordered pair 5 and 1/5 is not a solution.
We're almost done, guys. We're in the last piece. Woo!
All right, man, Mr. Finger, you're getting on my nerves. All right, sometimes you will have two equations, all right, and you need to find out if an ordered pair satisfies both equations. Basically, you're going to see if it's a solution, all right? So think of it like this. We have in this problem 7, 9, and I'm actually going to move this up just a little bit for you so we can do some work. All right. We have the ordered pair 7, 9. My question to you is, does it work for this equation And does it work for this equation? If it works for both equations, then this 7, 9 is what we call the solution to this entire system, because it's being 2 points. It's 2 equations that we're looking at. All right, and it has to solve for both of them. It has to work for both of them, excuse me. So let's plug in numbers. Well, this is going to be 9 times 7 minus 9 equals 72. Well, 9 times 7 is what? It is, excuse me, 63 minus 9 equals 72. Well, does 63 minus 9 equal 72? No, it doesn't. So this does not work. Quite frankly, we don't have to do anything else. The answer to this question is no. But let's go ahead and work the other side out. So let's try it out. 7 times 7 minus 3 times 9 equals 22. Well, 7 times 7 is 49 minus 3 times 9 is, excuse me, it's 27 equals 22. Well, 49 minus 27 is 22. Well, this side does work. But since the ordered pair doesn't work in both of them, 7, 9 is not a solution. Last problem. All right. The question is 3/4 and 2/5 a solution of the following system of equations? Same principle. I need to plug this ordered pair into both equations to see if it works. All right. So let's do it. 8 times 3/4 minus 15 times 2/5 equals 0. Alright, and because I'm lazy and I just don't want to worry with fractions, I'm going to go ahead and use my handy dandy calculator. I'm going to say 8 times, and always be smarter than your calculator. When you put fractions in, remember to use your parentheses. So 8 times 3/4 is 6. And I probably could have done that in my head, to be honest with you, but I'm being lazy right now. And let's find out what 15 times 2/5 is. That gives me 6 equals 0, and 0 equals 0. So this equation checks. Let's try the next one. 4 times 3/4 plus 25 times 2/5 equals 13. Well, this one you should be able to figure out pretty quickly. This is going to be 3 plus, what's this going to be? This is going to give me 10 equals 13. Well, 3 plus 10 is 13, and 13 equals 13, so that checks. And so, since both equations check with using this ordered pair, we know that 3/4 and 2/5 is a solution.
That is the end of this video. Again, as always, remember,
Ask, just ask.
yeah, ask questions. See you next video.
Bye-bye.